Right, so we have a question here. What's up, everybody? How you doing, man? Right, so they say find Maclaurin series of expansion sine square x to 3 times. So Maclaurin series formula is simple as this. So that's what you have to know first and foremost. Maclaurin series formula. Maclaurin series, let me write here. Maclaurin series solution. Maclaurin series formula say f of x equal to f of 0 plus, see this f of 0. So this one you derivate f of 0, just put prime, and they say x, see this is prime 1, this must be x power 1, and then you over 1 factorial. So now you continue, you do second prime, so face f's derivative again, and this must be x square over 2 factorial. You continue the same game, 1 2 3 and then 0, and this must be x power 3 over 3 factorial, f power 4. You see, continue all the way to the point where, so look here, if somebody give, let's say this is 2 3 4 5, so if this is, we don't know number, so what is number before? Number before, look, for example, if this is 5, what is this number? This number before means take 5 minus 1, means any number which is here, let's say we don't know this one, so the number before it must be that n minus 1. So now this, if this is n, this must be n minus 1. So if we don't know, let's say we don't know now because we don't know where we're going to stop, this is going to be f n minus 1, means the prime minus 1, and then para 0, and then we say over n minus 1 factorial, just like you see, if it's 3, we over by 3, and 3 prime. So n minus 1, this must be n minus 1 also factorial, and then this must be x power n minus 1, and then that's the number before the last one. So the last one is going to be power n. So the last one is going to be power n. So the last one is going to be, excuse me. So the last term, if that's n minus 1, so the last term, let me write here the last term. So the last term is going to be plus, it's going to be fn 0 x power n over n factorial. So now this is what we need to do. You know what I'm saying? So we need to do this. So let's go now. So f of x you're looking for means for the function means you have to expand this Maclaurin series. You have to get f of 0. So now we come here, right? F of what? F of 0. So now our f of x is the one which is given. So f of x equal to sine square x. So we need f of 0 for the first one. So it's going to be f means one f of 0. So you have to get this f of 0, f of 1 prime, f of second prime, f of third prime, f of blah, blah, blah. So we go f of 0 because we need to get that one. So meaning here is going to be 0. It's going to be sine square of 0, but sine square of 0 equal to 0. Now we go for the second one. So if you go for the second one, we see, here we go. So it's going to be f means find the derivative. So when you derivate this one, is easy. What you do, like if somebody gave you x squared, what you do, you take 2 at the back, and this is going to be x, 2 minus 1 equal to 1. So you do the same game here. So let's go. We're going to take this 2 behind, it's going to be 2. And if it's 2, means we have to drop the way how it is, which is going to be sine of x. 2 minus 1 equal to 1. So I don't have to write 1. Now you go derivate which you got here. When you derivate sine, you're going to get cos of x. So that is it, face prime. Now we go, we want to get f of face prime of 0. So f of face prime of 0 means you put 0 in here. Put 0 here, it's going to be 0. Also put here, it's going to be 2 sine of 0, cos of 0. Okay, sine of 0 equal to 0. So this is going to be 0 times cos of 0 equal to 1 times 1 times 2. 2 times 0 times 1 equal to 0. Now we go for the next one. So for the next one, excuse me. So we go for the next one. For the next one, we're going to get our second prime. So you have to get all those prime because we need to get 3 terms. So get the next prime. So let's get about 5 or 6. It's going to be make a lot of sense. So now go for second prime of x. So it means take this what you have and then derivate again. So remember this is a product rule here because you got 2 and this is first group, second group. So you have to do the product rule. So let me get a space a little bit. You know what I'm saying? So let me, okay, so second prime. Okay, so if it's second prime, we say, and before I go to the second derivative, remember this mathematical before I go to second prime. You see this, excuse me, you see this one here? Somebody could have said, even if I don't want to say 2 cosine, I say, okay, face prime, but whenever you have a 2 sine cos, 2 sine of angle, cos of angle, that same as say is sine double angle. You memorize this. You memorize. That one you memorize. 2 sine of angle, cos of angle equal to sine double of angle. So now, if I could have rewrite this, just in case, it was okay, so these 2 sine equal to sine double of my, what is my angle? X. So this is the same thing. Then I could have, instead of using this, I could have used that one. So either way. So I could say, okay, sine 2 times, what is my angle? Because we want to put 0 here. So I'm saying, like, if, let's say I don't want to do is it, the top one. So it's okay, so f of phase prime of 0 now, because substitute 0 equal to sine 2 times 0 equal to 0 also. Now we go for the second prime, and this is going to make me easier for me to get the second prime than if I could have done this is the product rule. But I could have done that too. It's optional. Now let's go for second derivative. So second derivative equal to, so I have to derivate this. When you derivate this one, what you do, if somebody give you, let's say sine of g of x, what you do, derivate your function which is in here, which is going to give you g dash right behind, and then when you derivate sine, you get cos of your angle. You see, so I could have done the same thing here for that one. Know what I'm saying? So write this on. So I could have done the same thing here. When you derivate 2x, means you derivate anything which is in here is going to give us 2, and then derivate everything. When you derivate sine of 2x, you get cos of 2x. So I'm saying, so now this is second prime. So say f of second prime of 0, means you substitute 0 is going to be 2 cos of 0 minus 2 times 1. Cos of 0 equal to 1 equal to 2. Now we go for the next one. So for the next one, you have to do what? Another derivative. So now we're going to get what? Third prime. So let's get third prime. So third prime is easy. So say f of third prime of x. So third prime of x, you say, okay, so now let's derivate this. So we do the same thing. Derivate whatever is in here. When you derivate 2x, you're going to get what? 2. And then you bring back, so it's going to be 2 times the answer which is get here. Because look, 2 cos of 2x. So we have a 2 here already. Derivate 2x, you're going to get 2. So you right behind that 2. And then when you derivate cos of 2x, it's going to give you negative sine of 2x. So put negative sine of 2x. So this is going to be negative 4 sine 2x. Negative 4 sine of 2x. So plug in there, negative 4 sine of 2x. So negative 4 sine of 2x. Now we substitute, substitute 0 there. Substitute 0 quick. So we substitute 0 here is going to be f of third prime of 0. Okay, this is going to be negative 4, and then sine of 2x. Sine of 2x means the sine of 2 times 0 now. So negative 4, sine of 0, sine of 2, 0 equal to 0. Everything is going to be 0. Plug in the calculator though. You can plug in the calculator. Now we want to go for 4 prime. So for 4 prime, you do the same game, guys. So now we go derivate whatever you have here. When you derivate 2x, you're going to get 2. 2 times negative 4 is going to be given negative 8. When you derivate sine of 2x, you get cos of 2x, brother and sister. So now we go plug it in here. So f of fourth prime of 0. If you plug in 0 here, 0 means it's going to be negative 8 cos of 0. Cos of 2 times 0 equal to 0. But a cos of 0 equal to 1. Negative 8 times 1 equal to negative 8. You know what I'm saying? How many terms? You want 3 terms. So for you to get 3 terms, look all the number, not the one which have given 0, the one which have given actual number. This is not going to give you 10. Because look, f of x equal to 0 means everything is going to be 0. So here we're not going to have anything. F of phase prime equal to 0 means f phase prime equal to 0. So 0 times anything is going to be 0. So we don't have any terms so long. F of phase prime, oh, it's the same thing. We say this is a alternative way of doing the same thing. F of the second prime equal to 2 means this second prime is going to give us 2. So when you take 2 times something, we're going to get something. So this is going to be our phase term. Now I'm saying this is not going to give us any term because it's going to be 0. F of the third prime 0 times anything equal to 0. But this is going to give us term negative 80, which is f of third prime. So we got to get one more. So we got to get a term which is going to give us number here. Now let's go, baby. So now we say, okay, so this is going to be f of fifth prime, so x. And now here, we're going to have to derivate this. So it's going to be negative 8 to derivate whatever you have here. When you derivate 2x, you're going to get 2. 2 times negative 8 is going to give you negative 16. And then when you derivate cos of 2x, you're going to get negative sine of 2x. So this is going to be sine of 2x, and then this because negative sign, so we're going to have to put another negative. So negative and negative is going to give us positive. How do I know this? How do I know if I differentiate sign I get cos? When you differentiate cos you get negative sign? From the differentiating table of trigonometric. Is there in your book, you know what I'm saying, or in a Google differentiating table. When you differentiate sine you get cos. When you differentiate cos you get negative sine. When you differentiate tan you get sec square. You gotta go and memorize those ones, a lot of them. Now we go. So this, now we have to post fifth prime. So our intention now to get something which is going to give us actual number, not 0. When you get that one, and then we know we're done. Fifth prime of 0. Okay, plug is 0 here, so we're going to go 16 sine of 2 times 0. Everything is going to be equal to 0 here. Let's go one more. We got to get this one, man. Okay, number 6, x. Okay, derivative whatever here is going to give us 2. 2 times 16, 32. And when you derivate sine of 2x, you get cos of exactly what you have here. So now let's plug it in. So for fifth of 0, so if it's 0 here, it's going to give you cos of 0 equal to 1, because it's going to be 32 cos of 2 times 0, because now we plug in x0. It's going to be 2 times 0. So cos of 0, because 2 times 0 equal to 0, cos of 0 equal to 1, 1 times 32 equal to 32. So I don't need to continue because they want 3 terms. But if they wanted 4 terms, then I could have continued so that I get a term which is gonna give me something which is not 0. So I got my 3 terms. So what I'm gonna do now, I just plug it in my given formula and finish all the business. So I can probably do here. Let's just do here. Okay, cool. So what we're gonna do now, we're gonna plug it in here. So we say, this is not going to give us 10, so I'm not going to bother. And this is not going to give me 10, because what I'm going to do, say, okay, this is going to be f of 0. So f of 0 is going to be equal to 0. So why bother? I don't have to bother with it, because that's going to be 0 straight away. You know what I'm saying? Now go. The phase prime look is going to be 0. So 0 times anything is going to give me 0. So no term, no term. Now come f of second prime. F of the second prime will give me 2. Yes, of course, this 2 I'll take it. So I'll say, I'll take that one. So it's okay. So f of x that I'm looking for equal to 0, 0. F second prime, we'll say f second prime equal to 2. So I'll say 2, this f second prime, and then we got x squared, and then over 2 factorial, and then we have a plus. Now we go f of the third prime. F of the third prime equal to 0. So I'm not going to bother with this. Not going to give me anything. Now let's go f of the fourth prime. F of the fourth prime equal to negative 8. Okay, so I'll say negative 8, even if it's not there, but we know it has to be x power 4, because fourth prime is not there, but we know if it's fourth prime, this number must be 4. And you have to divide by 4 factorial. Now we go. F of the fifth prime, number 5, no, is 0. So I'm not going to bother with it. I'll go to f of the sixth prime. F of the sixth prime equal to 32. So now I'm going to go, I'll say plus, remember this is negative, you know what I'm saying? Okay, I'll say plus f of the 6 prime. So it's going to be equal to 32. So I'll say my 32 x of the 6, because 6 prime divided by 6 factorial. And that's the end, man. So what we can do now there, this is plus and minus. Plus minus equal to minus. So say f of x equal to 2x squared over 2 factorial. Plus and minus give us minus, and then we got 8 x power 4 over 4 factorial, and then plus 32 x power 6 over 6 factorial. So I'm saying, so that's what you start there. So now you say, right, so sometimes some people, you know how to do, sometimes you know, some so you know how to do, they can simplify this. They say f of x equal to 2. Look, 2 over, we can take only these numbers. You can simplify, plug them in the calculator, you're going to get a number. Because it's going to be 2 over 2 factorial is like 2 times 1. This is going to give you equal to 1. So 1 times x squared is going to give you x squared minus. You do the same thing for the next one. You see 8 over 4 factorial. 4 factorial means 4 times 3 times 2. 4 times 3 is 12. 12 times 2 equal to 24. So 8 over 24, 1 over 3. So this part is going to be 1 over 3 x power 4. You can simplify further like that. You know, it's option if you want to do it like that. And then you continue, see, okay. So now let's go for the next one. So for the next one is going to be, Okay, so now you could do the same thing. So this is going to be x power 4, and then plus you do the same thing. They will say 32 over 6 factorial. You can plug in the calculator, and then you're going to get the answer, and then you're going to write that answer, and then x power 4, and that could be your final answer. Now we go. So that could be first part. So we go for the second part. They say use your answer in equation 1 to write down the Maclaurin expansion for sine square of x over x. Now we go. So what I'm saying. So let's play around, man. Let's say this is x squared. Let's just make it like that, just to to play around, to make it more interesting. So now let's go. So easy. So we want to say for a 2. So I'm gonna check. I can do here. See what I'm saying? I can do there. So for 2, question 2. So for question 2, look. So how are we gonna do it? Take your x squared over your sine of x, the answer which you got it over x squared. So what is my answer? This I can either take this or I can take the previous one. Let me take both. For example, if I took this, because they're both the answer. If I take the first one, so this is it, the second part. If I take this, I'll say everything divided by x squared. So say everything divided by x squared. So say 1 over x squared. It's like, look here, man. If somebody can say 8 divided by 2, you could have said 8 over 2. Or if you don't want to do that, you could say 8 times 1 over 2. So if you divide sometimes, say whatever you have times 1 of the number you want to divide. So now for this case here, I'm going to say, what am I having? They say here sine of x squared from the Maclaurin expansion over x squared. So I'm going to say 1 over x squared times what I had. What do I have? 2 over 2 factorial x squared minus 18 x power 4 over 4 factorial plus 32 x power 6 over 6 factorial. I hope you can see that. Let me just move a little bit. My apology. My bad. X power 6. So now what we're going to do, look here, man. So I'm going to take, look, 1 over x squared times what? Only with the x, because I want to cancel with x. Times this one. Look, x squared is going to cancel. So if x squared and x squared cancel for the first one, I'm going to have this, and this cancel is going to be 1 times 2. 2 over 2 factorial is going to be 2 over 2 factorial. And you can plug this in the calculator, get the answer. Minus, this is x squared and this x power 4. But this is underneath at the denominator. So it's like 1 over x squared times x power 4. 2x and 2x goes. It's going to be x 2 power x on top. So on top. So now this is going to become 1 times 80 is negative 80. And then x only power 2 because 2 is gone over 4 factorial. Now we go for the last one and do the same game. So 2x go with 2x. So we're going to be left with 4x there because 2x and 2x. So we're going to be left with only 4. So it's going to be 32 x power 4 over 6 factorial. And what you can do there, you can plug in a calculator. Means 2 over 2 factorial, you're going to get actual number. 2 over 2 factorial is going to give equal to 1. So here it's going to be 1 and then minus. And this is going to give us 1 over 3. 8 over 4 factorial 1 over 3. X squared plus 32 divided by 6 factorial. You get the number. You write that number. X power 4. And that's going to be the second party. Now let's go for the third party. Third party. Right, so now we want to finish the last party. So the last party, they say determine sine. Easy, man. Sine of what of? X, sine square over x, where x equal to 0. So this is a limit, normal limit. So say for third party, let's do it. Easy. So let's plug it in. So what we're going to do, they say limit x equal to 0. Means substitute value of x equal to 0 and see what's going to happen. So if we take this x plug in there, it's going to be sine of 0. There's a square here over 0. So this is going to give you 0 over 0. And this is unacceptable mathematical. We say this is undeterminant. Excuse me, this is called undeterminant. Undeterminant. So if this is undeterminant, so my handwriting, undeterminant. If it's undeterminant, determinant and determinant. So if this is undeterminant, you know how to say if it's undeterminant. How do you know undeterminant? Undeterminant is only when you have a 0 over 0 we call indeterminate, or you have infinity over infinity. So this you call it what? Indeterminate. So when you have that, that situation, what you do, try to differentiate numerator separately and denominator separately. Listen, this is very, very important. Please do not do quotient rule. You see, do not do as a quotient rule, because it looks like a quotient rule where you can just do differentiation by quotient rule. But don't do that. Don't do that. Do El Hospital rule. So what is El Hospital rule? El Hospital rule, let me write here. El Hospital, not El Hospital, El Hospital. Like just like a hospital, but I don't write here has. It's just L and then Hospital, not S, not hospital, Hospital. Just like a hospital, but I don't write that S. So El Hospital means take the numerator differentiate and denominator differentiate. So if we differentiate sine square, but we had this before, so I don't have to differentiate here again, because when you differentiate sine, look, we get this, we did it already. When you differentiate, you get sine 2x. So this on top is going to give me sine 2x, you see, and the denominator, if I differentiate x, is going to give me 1, and we still have our limit. Our limit, x goes to 0. Now let's substitute now. So if we substitute, if it give us undeterminate, then we have to do it again. But if it does not give us undeterminate, then we're fine. Now I'm going to take x, plug in here. So this is going to give us, when x equal to 0, it's going to be sine of, look, sine of 2 times 0 over 1. But a sine of 2 equal to 0, if we plug in the calculator, you're going to get 0 over 1 equal to 0. So for this case, our answer equal to 0. And that's the end of the question, man. Thanks a lot for your time, and peace and love, brother and sister. King of Queens, peace. Thanks a lot.
More ring for my queen. You gon' wait me till Jesus come. Why when I talk? Pocket full floss, money, honey. Forget about Suzanne.
So since we don't have all the equipment like cameras and all this stuff, so just use one of the webcam from my computer. So we're gonna start with these tools and give people knowledge, because that's how they say, start with what you have, and then from there you're gonna elevate it. You're gonna elevate it, and things gonna propagate it, and excuse me, and things gonna improve slowly, because you can't reach down top before start from the bottom. Otherwise, then you're gonna break and start from bottom.